All right, so 7.7 is all about solving, right? So we first learned about logarithms in 7.5, and then our last section, 7.6, which we just got done, we learned how to expand and condense. So now we're going to start to actually solve some of these. But if you can, you want to try not to have to use logarithms. There's nothing wrong with logarithms, but they can make things a little bit more complicated. So we're going to go through some examples today of how you can try to solve when your variable is in the exponent without actually using logarithms. Amber, are you with me? Can you put your phone away? So that's the goal for this first part of 7.7 is to solve them when they're still in exponential form without having to rely on logarithms. So some things that will help out. If we have a to the x is equal to a to the y, then x is just equal to y. We can kind of cut out the base. We know our exponents would have to be equal at that time. We may have to convert exponential equations to logarithms and vice versa. Right? We're going to have to use all of the properties that we know about logarithms, where we may have to go back and forth, right? These are like the tools in our toolbox, right? And we're going to use them whenever we need to. And then the last one, this is not something we're going to do today, this part of 7.7. We may take the log of both sides. We may say, okay, how can I get rid of kind of all the other stuff and just focus on the exponents? Taking the log might help us do that. And always check your solutions. There is an opportunity to get extraneous solutions. They will come up, so we must check our work. So we're going to start out small. If I have 7 cubed is equal to 7 to the x power, what does x have to be? 3, right? This is exactly right. 3 is just equal to x, right? In order for this to be a true statement, the x value would have to be 3. Right? Looking at letter B, we have 5 to the 3x plus 1 is equal to 5 to the 2x. We have the same base here. I can just cut that out and say, okay, 3x plus 1 must be equal to 2x. Now we just have a two-step equation. Subtract 3x, or subtract 1, whatever makes the most sense to you. I get x is equal to negative 1. And then we can check, right? Plug it back in. 5 to the negative 3 plus 1, which is negative 2, is equal to 5 to the negative 2. Yep, it all checks out. All right, letter C, very similar, right? We have the same base, so we can just kind of set our exponents equal to each other and solve. I get x is equal to negative 5. And then letter D, I threw that in because I know how much we like factoring, right? We have the same base here, so I can just set my exponents equal to each other. Now, in order to solve this, I need to set it equal to 0, factor, and solve. So I'm going to add x to both sides, subtract 3 from both sides. Get 0 is equal to x squared minus x minus 6. Then, right, I kind of think of my x marks the spot, what multiplies to give me negative 6 and adds to give me a negative 1. Negative 3 and positive 2. Perfect. So this factors down. X minus 3, x plus 2. Set each of my factors equal to 0. I get x equals 3, x equals negative 2. Did I go too fast on that? Are we okay? Good? Okay. So let's look at what happens if I don't have the same base, right? We cannot just go right to that second step and set our exponents equal to each other. It's not possible. So we need to rewrite one side of the equation so that they have the same base. And by base, right, I mean the base part of our exponential form. So here's what I recommend. Always have a positive and try to have a whole number base, something between like 1 and 9, with numbers that we're used to. So what I like to do is I say, okay, 3, that's not, I don't want to change this to 1/9, right? 3 is a number I'm familiar with. How can I rewrite 1/9? 1/9 is equal to 3 to what power?
-2.
-2, that's right. It's a negative number, right? If I go from a fraction to a whole number, I'm going to have a negative exponent. So 3 to the -2 is the same thing as 1/9. Are there questions on that before we kind of use that? All right, so I'm going to take this, and I'm going to substitute it back in for 1/9. So I get 3 to the x is equal to 3 to the -2 raised to the x plus 3 power. Now, when I raise a power to a power, what do I do? I multiply, right? So I have to multiply these together, which means, right, I get -2 times x plus 3. I'm going to have to distribute that -2 through the expression x plus 3. So I get x equals -2x minus 6. Add 2x. 3x equals -6. X equals -2. Questions on that one? Because this is when it starts to get tricky, right? You're going to figure out that it's 3 to the -2 power. But then you might plug it back in the wrong spot. Remember, we're substituting in the value. These are the same thing, right? 1/9 and 3 to the -2 mean the same thing. All right, next example. So I want a whole number base, positive, between 1 and 10, so I'm going to stick with 7. How can I rewrite 49?
7 squared.
Perfect. So I substitute 7 squared back in for 49. 7 to the x is equal to 7 squared raised to the 5x plus 18 power. I, at that point, have the same base, so I can kind of cut out the bases and just set the exponential expressions equal to each other. I must distribute that 2 through. And then I've got a 2-step algebra equation. Move all my x's over to one side. I get -9x equals 36. X equals -4. Did I go too fast, or is everybody doing all right? Okay. All right, let's look at letter C. All right. Again, my recommendation, a positive base, whole number between like 1 and 10, kind of small. Can I rewrite both sides of my equation with a common base? What common base stands out to you? 9. 9 would be okay. I went even further. I did 3. Because I didn't want to get this messed up, but yes, we could do 9 as well. But let's do 3. So I have 3, and I have to figure out 3 raised to what power is 81?
4.
Thank you. Right, so I replace 81 with 3 to the 4th. And then over here, I replace 1/3 with 3 to the -1 power. Now I just have a good amount of algebra to do, right? Stuff we know. 4 times the quantity, 3 minus x, is equal to -1 times the quantity, 5x minus 6. Distribute. X's. Subtract my 12. Right, lots of different ways to get the correct answer. I get x is equal to -6. Once you get letter C done, try letter D on your own. This is our last example together in our notes for today. You should get a fractional answer on this one. Don't be afraid of the fraction. I get x is equal to -1/3. Alright, so that kind of concludes the first part of 7.7. You have a worksheet in your packet, so it's right after the 7.6 worksheet, and it's like a spell out the word, spell out the phrase, or whatever it is. That is kind of your in-class assignment to get working on right now with a partner. It's kind of easy to see what the word spells if you look at all the letters, but I just wanted us to get a little bit more practice. Your homework assignment that goes with this is the 7.7 Part 1 worksheet. But it has a lot of questions, and I don't think we need to do all of them. So do we want to do evens or odds? Odds?
Yeah.
So odds are your homework that go with this one. Again, I did not care if we did odds or evens. I just figured we probably didn't need to practice it 24 times. One thing that I have noticed about the homework worksheet, because I got this from online, I did not create this homework worksheet myself, is they will often use an exponent of 0. Okay? So what is, if you have an exponent of 0, what is the value equal to?
1.
1. So if you see something like that, know that you can always choose any base you want, right? If you have it equal to 1, just the exponent would be 0. So before you can get working on the homework though, work through the little like matching and spelling the word. Feel free to work with a partner. I'll be walking around to help. And then you have those 2 homework worksheets to get done. Clayton, your question?